What's going on, guys? So today we're gonna discuss two-sum problem, and it's like that. So given an array of integers, we have to return indices of two numbers such that they add up to a specific target. So target is given and we have to find indexes of two numbers that if you add them up, it becomes a target. So let's see how we can do that.
Alright guys, so here's the problem. So we are given an array of integers and the target is 9, and we have to find two indices that if you add them up it comes to 9. So if you are in an interview, just always start with the simple solution. Even though it takes a longer time, just start with the simple one and then try to optimize it. So in this case, if we start with a brute force solution, you can have a for loop that goes through the array given, access each element, and try to find if the target minus that element is in the array or not. So let's see how we can code that. So you're gonna have a for loop that starts with 0, goes to its size, and then add 1 to it, and then you array of I, and B is your whatever target minus A, right? So and then you can have another for loop that goes that starts from j is equal to I plus 1. So if this is I, it goes here and tries to find the b. If b is there, so it starts from j plus 1 to goes to the end, and if that array j equal b, then you can just return ith index and jth index, and you can break the loop here so it doesn't go all the way to the end. Okay, so that's the basic what we gonna do. You assign a to whatever element you are on, then you try to find whether b, the target minus a, is in the rest of array or not. If you find it, you return both of that index I and j. So let's try to code it up.
Okay, guys, and because we had a nested for loop, it's gonna take O of n square, so that isn't pretty good. Then we are gonna optimize it, but let's just code it up real quick. So let's do, first of all, we are gonna return two integers I and j indices, so we can put them in the vector because we have to return the vector. Let's say call it a result vector that's of integer, and then this big for loop that goes from starting to its size to the end. So it goes nums dot size and I plus plus, and then int a is whatever element you are accessing right now, and int b is gonna be your target minus nums I, that, or maybe we already found num cycle, make it a, and then you are gonna go to find whether b exists in that rest of the array or not. So that inner for loop starts from I plus 1, goes to j is less than at, goes to the end j plus plus, and then you are saying if b equals nums j, then it means that you found that index j, whatever number is there, plus a is gonna be your target. So you can just push that value in your result vector, right? So push I, and you can result dot push J and break the loop, because you don't need to go all the way down. You already found what you were looking for, so just break the loop here. So once you found it, you don't need to go all the way to the end. And then outside of the bigger for loop, you can just return result, right? Result. Okay, let's see if this works. Okay, so submit this. Alright, so it works, guys. Now let's see how we can optimize it.
Alright guys, so our brute force solution took O of n square time, and it turns out we can make it better. But since we have to return the indexes, if we sort this, then we are gonna lose those indexes for that number. So we cannot sort this. So there is another way. If we put this in a hash map, so once this is in the hash map, it just needs O of 1 to access it. But we have to return indexes, so the value of hash map should be index, because that's what we care about. So let's see if we have a big for loop, goes through each element, and if we pass that element as a key to hash map, so this is gonna be key, and that value of indexes, so if you pass 2, then we're gonna save this 0 as the value of the hash map. So let's see how we can use this O of 1 access time to our advantage. So if you have a hash map, let's call it HM hash map, have a big for loop that goes through each element, and we can save that. So hash map, and the key is gonna be each element, where value is gonna be the index of that element, right? And we can say that if the target minus whatever element we are, let's say if this is the first one, if this is 2, this is 9, so if 7 is already exist in the hash map, then we can just push back the value of that element, which is 2. So value of 2, value is going to be the index of 2, and we can push back the value of target minus 2, so which is 7, if it already exists. Okay, and if it doesn't exist, you put that element in the index. So the basically what we are saying is, let's say if you are going through 2, first is 2, so we are saying in the hash map whether 7 exists or not. If it exists, we get the index of 7, and we already have the index of 2 from our for loop, that int I is going to be the index of 2. If it doesn't exist, we put that 2 in the hash map, and then we go again, and then we say, okay, now my element is 7, and 7, 9 minus 7, 2. whether 2 exists. Yes, 2 exists in the element in the hash map. So you return the value of 2. You already put it, that's going to be 0, that index, and you return the value of 7, which is just your I, right? So let me code it up and maybe that will make it more clear.
Alright guys, so let's first define our output vector, which is gonna consisted of integer. Call it result, just like the brute force, and then let us have unordered map, which is the C++ of hashmap. Under the hood it's unordered map, which has the access time of O of 1. You can directly access it. It goes to a hash function and you can directly get to that bucket. Key and value both are integer. So the key will be the element itself, element. And the value is gonna be the value is index. So what we care about is the value. We want to return the indices. Okay, let's go to here. We want to return the indices. Okay, so that's our hash map, and then we can see for int start to end and nums dot size I plus I plus, and guys, that I is the indexes of whatever element, so we care about this. So let's say if, let's put that nums I, okay, is equal to that index, right? We put the key, that element, and the value is the index of that. But if you already have it there, let's see, if, as we say, if fine, if you already have the target minus nums I, right, nums I is not equal to hm dot end. So basically, if target minus element in the hash map, right, then we can just return the value of that difference, value of that element, and the I is, let's say, so I is the index of the element that you are worried about, you are encountering right now, and that other value, which is gonna, the key of is this target minus element. So if you can find that, well, if you have that already in the hash map, that you can just return, so that result dot push back the value of target minus the element you have right now, and the second index result dot push back second element is just gonna be your I. Okay, so as we see, if you have two, right, so if you are in the first iteration of your loop, 2 is gonna come here, but 9 minus 2, 7. Okay, 7 is not in there right now, so you add 2. But when you come to the second iteration, and it's gonna ask 9 minus 7, 2, but yes, 2 is in the hash map, so you are gonna return the index of 2 and the index of 7, that being I. Okay, so once you are done, you can just break the for loop here. You don't need to go all the way, so you just put in the hash map if the difference is not there, because one index you are keeping track with this for loop, and the second index is gonna, you are gonna get from the hash map's value. So you don't need to put two values in the hash map, right? Okay, so let's see. Okay, okay, unordered. Let's see. And if I control, okay, then I have to return a result vector. All right, let's see. Okay, this works. So that's that. Okay, guys, so if there is no such element that adds up to our target, then this is not gonna be satisfied, this if condition, and we are gonna continue putting things in our hash map. So at the end we are gonna return the result, which is gonna be an empty vector, and if the result is empty, it's gonna mean that we don't have two elements that add up to target, so we cannot return the indices of it. So basically the big picture is we are going to put everything in the hash map, but if the target minus what we are encountering right now, if that is already in the hash map, we are going to return the indexes of that, and we are going to return the indexes of what we are encountering right now. So if we do that, we don't have to put what we are encountering right now in the hash map, right? So that's the gist of it. All right, guys, thank you so much.